Have you ever seen numbers spin in a loop? Not just repeat, but rotate perfectly? Welcome to the curious world of cyclic numbers, where digits dance in circles and math feels like magic, inspired by a humble genius, Dr. Kaprekar. Kaprekar didn't care much for fame or fancy equations. He believed numbers had stories. And one of his favorite number came from something simple as 1 over 7 equals to 0.142857 recurring. Today, I'm going to discuss this with two of my students. Let us enjoy the journey of learning and discovering new things beyond school curriculum. Hello, how are you?
I'm
I'm
good.
good.
How are you?
Very good, very good. So, I would like you to introduce to my subscribers. We are going to record today's class. Let them know who you are and how are we related. So let's start with you, Anthony.
Hi, I'm Anthony. I'm here in Mississauga, Ontario, as a math student for Mr. Anil for 1.5 years.
How about you, Anne?
My name is Ann Thomas. I'm in grade 7. I live in Mississauga, Ontario, Mississauga, and I've been studying with Sir for like a year and a half now.
Great. So I'm Anil Kumar, as you know, and I've been teaching them for a year and a half. They are twins, so that is something very interesting, and they are brilliant students. We are going to do our first recording on a very interesting topic, which relates to my upcoming book, Inspired by Math. So, Inspired by Math is basically inspiring students to learn mathematics, discover new things, and don't get bogged down by formulas and all those things. Get them interested and get them going. So my very first question to both of you is, and can you tell me what are the topics in math which you are really scared of?
For me, the topics in math that I would be scared of is decimal numbers and probability.
Oh my god. Okay, how about you, Anthony?
For me, it would be fractions, probability, and some algebraic problems.
Great. So in grade 8 I definitely see those are the things, but there are a few things which is common between two of you, and those are fractions and decimals, right? So
Yeah.
today my concept is based on fractions and decimals. These are actually troublesome for some students, but we are going to make them friendly today.
Yeah.
You you will
Guys,
definitely
don't feel
learn.
scared. Don't feel scared.
Yeah, that's so true. So we'll begin with reciprocal of numbers, which will give you a fraction. So do you understand what is a reciprocal?
It's when you like, flip the numbers in a fraction.
You're right. So when you flip the numbers, it is reciprocal. So what is the reciprocal of 2? It will be 1 over 2, right?
Yeah.
Reciprocal of 3 will be 1 over
For
3.
3.
And what is the reciprocal of 2 over 3?
Uh, 3 over 2.
2.
3 over 2 is correct. You just flip them, right? So we'll keep the fractions simple for now. So first exercise is we'll try to calculate some values, right? And you can use a calculator, right?
Thanks.
So I
I'm
also have
here.
a calculator here. We are going
What's
to
a
use
calculator?
calculator so that it's fast and efficient. Well, you could do this exercise without calculator also. So let's find reciprocal of our natural numbers, and let us say let's begin with 2. So when I do 1 over 2, what do you get?
0.5.
Correct.
0.5?
So 0.5 is a decimal number. It has terminated, and we call this as a terminating decimal number, 0.5. Now you do 1 divided by 3. What do you get?
Uh,
I get
0.33 repeated.
Repeated. So 0.33 repeated or zero point 0.3 recurring is what you get. So sometimes you get a number which terminates, and sometimes you get a number which does not terminate but it repeats. So it has a pattern in it. Do you see that? So decimal
Yeah.
numbers do have patterns. We need to recognize these patterns, correct? And when do we get repeating and when don't we get repeating is what we are going to consider soon. What is 1 over 4?
Oh,
0.
1/4. 0.25.
Correct. It does not repeat. It is a terminating decimal. Two decimal
Yeah.
places, 1.25. How about 1 over 5?
1/5. Well, that would be 0.2 as
1 over 6.
1/6.
6
0.16
repeated.
repeated.
6 is
Jinx
being repeated.
percentage.
1 over 7.
6 repeated. Okay. Oh, got it. 0.14.
0.142857, and it could
Oh
repeat.
my
Okay.
God. So how
It's
many digits
repeating.
are there which repeat? I think
Uh,
now
n-
we need a board,
none.
right?
Well,
Now we need a
16.
Yeah.
board. Oh my God.
Yeah,
So
we
let's
need the
write down this
whiteboard.
number. So don't you find this number very interesting?
Oh,
Yes.
yeah.
It is unusual
Really.
and it's very different from the others which we were working, right? So we just saw
Yeah.
that 1 over 3 was repeating and was zero point 0.3 repeating. We could also write in shortcut by a bar on 3, correct? And then we
Yeah.
came across 1 over 6, which was 0.16 repeating, correct? And all
Yeah.
of a sudden, when we checked on 1 over 7, what did you find?
It's like fully like there's a lot of numbers that
A lot of numbers.
no
Can
number
you tell me those numbers, please?
zero
0.
point one four two eight five seven one four two nine.
Correct. So 0.142857 repeats. So that is very interesting. And as we found it interesting, Kaprekar, one of the great mathematicians from India, also found it very interesting. But like a good student, he actually did not stop here. He kind of worked on it, right? Because this is unusual, right? How many digits are there which repeat? Can you count them?
Uh,
One, two, three,
two,
four,
three,
five,
four, five,
six.
six.
So when I'm dividing by 7, we are getting something which has got 6 digits which is being repeated. Do you see that? 6
Yes.
digits are repeated.
Yeah.
So that's very unusual. So he thought, let me work more on it. And let's discover what he also discovered in his own way, right? So, so what number we got here is called cyclic number, and let's understand why it is called cyclic number. We have 142857, correct?
Yes.
If
Yes.
I times it with 1, I will get 142857. Not an issue,
Yeah.
right? But let me times it with 2. What do I get? Use your calculator and tell me the value.
Okay. 142.
I get 285,714.
285714,
Spot on.
correct?
Yes.
Yeah.
Okay, so now let's do it. 142857 times 3. What do you get?
Uh, can I say this? I got it.
Yeah, say that.
428571 or 42,840.
Okay, if I times it with 4, what do I get?
You get 571,428.
Do you see a pattern coming along?
Yeah.
Times it with 5, what do you get?
I get 714.
704,285.
Times it with 6. There were 6
Oh, I
digits
got
here,
it.
right?
I got it. I got it.
So what do you get? Tell me.
857,142.
Do you notice a pattern in these
Yeah.
decimal repeating things? What pattern do you see? Tell me.
all the numbers like come out to be 6 digits.
And look here, 142857. Let me write here 1, 4, 2, 8, 5, and 7. So that is what the number is which we started with. And first time when you multiplied by 2, what did you get? You get 285714. 285714. Do you see the cycle? The
Yeah.
order did not change. The starting number changed. Do you see something very interesting? That is what Kaprekar saw and gave it a name, cyclic numbers. Do you see how interesting he made math? The whole idea is to find the patterns in these numbers, right? Not to make you remember formulas and make it boring. He made the subject so interesting for students. Now look here. When you multiplied by 3, what did you get?
I got
428571.
Someone.
So you see 428571. Do you see that? Again, the same order was maintained by these numbers. Correct? Next number is 571428. So you start with 5, 571428. That's the beauty of these repeating decimals, 1 by 7, which gives you 142857. Do you see how beautiful the number is?
Yeah.
And next, when you multiply this with 5, for example, you get 71428, correct?
Yeah.
And also with 6, you get amazing pattern being repeated with the same digit order. 857142. 857142. Correct?
Yes.
So we discovered a very beautiful number which we get by reciprocal law 7. 1 over 7 gives you a number 0.142857. And if you multiply this by 2, 3, 4, 5, or 6, you get the same digits. And the order is also maintained. Isn't that beautiful? Right? So now, what we discovered just now is that these fractions and these decimal numbers can be beautiful. They have order. It's like dancing and positioning in a different way, but the same order. Correct?
Yeah.
Now, you'll be surprised to know that these are not the only cyclic numbers. There are many other cyclic numbers. How do we discover them? So there are a couple of ways to discover. One is keep on dividing the number by 1 by these numbers 1, 2, 3, 4, 5, 6, 7,
Just
go
use
on.
this thing.
Right? You can do that. And then what you need to figure out is a special property. And what is that special property? When you divide it by 7, you got a 6-digit repeating numbers. Do you see that?
Yeah.
Another cyclic number will be 1. If you divide by that number, you should get n minus 1 digits repeating. Right? If you take number, for example, if you take 13, and if you divide by 13, and if you have a set which has 12 decimal, 12 places, 12 digits after decimal repeating, then it could form a cyclic number. So that is kind of a thing which we are looking into, right?
Yeah.
Right. Now this calculator, if I divide by a number, I cannot get so many decimal places since we are restricted, correct? But actually, if you go with a bigger screen and a lot of numbers, there are many interesting numbers. Can you figure out ways of doing it? Maybe some other device, right?
Yeah.
But it was interesting to see that we have decimal numbers which have cycle in them, and this cycle is maintained even after multiplying them with different numbers, right?
Yeah.
Okay, so there is another number which can give us like 1 over 17. If you divide by 17, you get the same order. I mean, cyclic number. But you need to figure out what is 1 divided by 17 and then try it out, multiplying by 1, 2, 3, 4 till 16. You will maintain the same order.
Yeah.
Isn't that very interesting?
Really cool.
Yeah. So, this is what you need to explore while we are working with numbers, right? So, once you do 1 over 17, go with prime numbers. Divide by prime numbers to get your result faster and discover many of them, which can form a cycle just as we did. Correct?
Correct.
So that is what greatness about our legends is. Kaprekar discovered many other numbers like this, and we have many numbers in his name, which we'll discuss in another video. I hope you found this interesting. Great. So,
Great.
so tell me, what did you learn in today's lesson about the cyclic number?
We learned that when you're dividing, like multiplying, you take the number that repeats and you multiply it by numbers like 1, 2, like 2, 3, 4, 5, and 6. Then it goes in a cycle and then it just repeats in the order.
Yeah, so that's the interesting part. And it will happen with the numbers where the number of digits which are repeating is just one less than the number itself. So that is kind of very important thing, and something which gives you a hint. How do I find the next number which is going to be a cyclic number, right? So now your exercise is to give me next two, since I've already given you hint that the next number is 1 over 17, which will give you a 16-digit number that repeats. Correct? So next class when we meet, I am expecting from you another number which could result into cyclic number. Perfect. So that's it for today. See you in the next class. Thank you. Bye. All the
Bye.
best. Bye. Thank you.
Yeah.
Cheers.
Bye.
Now it's your turn to think boldly, explore patterns, and ask powerful questions. With every video, we'll guide you step by step. Because math is not just what you learn, it's how you think. Inspired by Math is for curious minds, creative thinkers, and junior mathematicians ready to explore the world with numbers. Whether you're a student, a parent, or a passionate educator, this journey is for you.